like, so this is like, we call these linear factors. Linear factors. So you do that. The second type is of this same linear, but maybe you have a square there, or maybe you have this. So because of the square, you do a over x minus a plus b over x minus b. And then if you want c over x minus a squared. So that part, if you want to remove it, you put x minus a squared if it's repeating like this. So you're saying this and this, that's the arrangement that they take. The third one is if you have g of x over x squared, maybe plus a, and then x maybe plus 1, then it will be ax plus b over x squared plus a plus c over x plus 1. So this is because we are unable to factorize this part here. So, and that the difference between the powers of the denominator and that of the numerator should be 1. Okay, so you need the difference to be 1 there. And then the fourth one is where I have this over x squared plus a squared, maybe x plus 1. Then it's going to be ax plus b over x squared plus a plus cx plus d over x squared plus a squared plus e over x plus 1. So this is where partial fractions end. Do we have questions?
Sir, is it always that on the formula, the a over, for instance, a over x minus a, it's always positive, as in the sign in between is always positive?
Yes, until you find b. So in the formula, it's always positive. Who has a question here? We want to move on. This is where partial fractions end.
What if x on the denominator has a power of 3?
Then you factorize and put them in linear.
What if the numerator has an x, maybe an x cubed or anything like that?
Okay, so now we're going to examples where you have those varieties. So what happens is that if the power of the numerator is higher than that of the denominator, you first use long division so that the powers can be reduced, and then you fall in these 4 types. That's the only extra information. So I come back here and say, note that the power of the numerator should should always be less than that of the denominator for these four types to work. If that is not the case, what do you do? Yeah, this is the first screen, and there's really nothing much to explain here. We're just saying we have four types, and type 1 takes the linear denominators. Type 2, they are still linear, but one of them is repeating. Or if both are repeating, that's how you put them on under A, B, C. Type 3, if you have a quadratic that you're unable to factorize, then it means on top you're going to have the linear function as well, ax plus b, to sit on top of that quadratic. Type 4, if the quadratic is squared or is to the power 3, it will keep on appearing here until you have covered all the powers, like that. And most important is that for all these four types, the power of the numerator should always be less than that of the denominator for these four types to work. Okay, if that is not the case, use long division until you have those cases. Examples.
Saka previous slide if no.
I don't understand that language. Chelsea was wired yesterday. 3-0. Are you done with the slide? With the screen?
Just 10 seconds, sir.
I thought you had screenshot it. You look like you just fine.
I'm done, sir. I'm done.
Okay, examples. A. Resolve into partial fractions. Resolve into partial fractions. Let me use numbers today. 1. X squared plus 1 over x squared minus 1. Have you seen that the powers are equal? So this is not working. We want the powers to be, the powers of the numerator to be less than that of the denominator. Now here they are equal. So what do we do first? We first use long division. So we do long division. We get x squared minus 1. And then x squared plus 1. Then divide x squared into x squared. We get 1. Multiply. We have x squared minus 1. Subtract. So we get 0 plus 2. What does this mean? We can now write x squared plus 1 over x squared minus 1 as the quotient 1 plus the remainder 2 over the divisor. x squared minus 1. And then we go further to show that we are able to factorize the difference of two squares into x minus 1 and x plus 1. It has now become linear. And so we pick 2 over x minus 1, x plus 1, and write as a over x minus 1 plus b over x plus 1. And then we cross multiply. So we have 2 is equal to a. So here you just cover this one. When you're on a, you get the denominator of b. And when you're on b, you get the denominator of a. Multiply like that. Then there are so many ways. If you want, you can expand here. You can expand and find a and b, or you can use elimination. So if you use elimination, using elimination, method. This is just for sake of explanation. Don't. The problem is that whatever I write here, you write when you're answering. I won't write it. So let x be equal to 1. Then we'll have 2 is equal to 2a, because this one will be 0. This is telling us that a is equal to 1. Again, let x be equal to -1. This will be 0. And then we'll have 2 is equal to -2b. So that b is equal to -1. So this is b, this is a. Then you substitute there. So you're saying therefore x squared plus 1 over x squared minus 1 is equal to 1 plus a is 1 over x minus 1 minus b is -1. That's how I put a minus x plus 1. That's how you do partial fraction composition. Any questions?
Sir, just repeat your explanation on step 2.
Where is step 2? Which one are you calling step 2?
Okay, after the long division.
After long division, then you factorize the denominator. It becomes the same. Then you just pick this. You pick this into parts. That's the one that you resolve into parts. And because the denominators are linear, we are back. Type 1. So just split by putting a, b on top there. And then do the cross multiplication. Then solve for a and b. Like that.
Sir, what did you say? Why are you bringing in the long division again?
It's because we wanted the powers of the numerator to be lower than that of the denominator.
Sir, so always the powers of the numerator should be lower than the powers of the denominator.
This one, take note of this. Put it in red. This Very, very important. Okay.
So what do you do if it's greater? If the numerator is greater, the power of the numerator is greater than the denominator.
It is. Use long division.
Sir,
Hello.
there on the let x equal to 1, let x equal to -1. I didn't get that part.
Also, here we are trying to solve for A and B. And then we are using elimination method. So if we let some numbers that can vanish together with B, then we'll find A. Or together with A, then we'll find B. Well, you are free to pick any value of X. But you can make a good choice that can help you find this easy. So if we say X is equal to 1, we know that 1 minus 1 will be 0. But then here, 1 plus 1 won't be 0. So it will help us get A. You come back and say, what about -1? -1 plus 1 will be 0 here. But here, -1 minus 1 will help us get the value of B. So I've made the good choices of A and B that will help us, of X that will help us get A and B. Like that.
So, sir, our area of interest here is to find a value that is that will eliminate either A or B.
Yes. What about target? Okay. Another example. 2. 10x plus 93 over x plus 10 squared. So here, the power of the numerator is less than that of the denominator. So we go straight and say A over x plus 10 plus B over x plus 10 squared. The power of x is 1 inside, but then it is squared, meaning it's repeating. So what do? We go on and say, oh, so this is 10x plus 93 is equal to A x plus 10 plus B. So remember, you always, when you want to get rid of the denominators here, you always multiply it by the common denominator, which is x plus 10 squared. So that this one cancels this one for the left part, And then this one into this, it will leave out one of them because of the square. That's why we have it here. And then this guy in here, it will take away everything. So we just remain with B. Like that. Then now, to find this, maybe we don't use elimination. Let's now use another method. You expand. So A times X, we get AX, plus 10 times A, we get 10A plus B. If these two sides are to be equal, the coefficients of X should be equal. And the constants should be equal if the two sides are to be equal. This means that AX should be equal to 10X, which implies that A is equal to 10. 1. And this means that 93 should be equal to 10A plus B. But we know what 10 is. What A is. A is 10 plus B. So this goes the other side. So we'll have 93 minus 100 is equal to B. So that B is equal to -7. Like that. So we're saying therefore 10x plus 93 over x plus 10 squared is equal to 10 over x plus 10 minus 7 over x plus 10 squared. Any questions? This was like a simple task. Okay. Another one. 3. 24x squared plus 2x plus 117 over x multiplied by 2x squared plus x plus 13. Oh, just be fast a bit. Okay, so this we'll have a over x, this linear here, plus Well, because you can factorize this quadratic here, when we put bx plus c over 2x squared plus x plus 13. This is because we cannot factorize this quadratic. If you were able to factorize, you can factorize it. But we can't factorize this thing. It's unfactorizable because there are no factors. The product is 26. The sum is 1. So you can't find such numbers. So you do that. And then this means you remain with 24x squared plus 2x plus 117 is equal to a multiplied by 2x squared plus x plus 13 plus bx plus c multiplied by x. If we expand here, we'll have 2a x squared plus ax plus 13a plus bx squared plus cx. What does it mean? For these two to be equal, the constants should be equal. These without x, they should be equal. So we want 13a to be equal to 117. Divide by 13, divide by 13. This means that a is equal to 9. We divide there. Next, we want these with x. These with x plus this, these to be equal to the coefficient of x this side. So say ax plus cx should be equal to 2x. This simply means a plus c should be equal to 2. But because we know a is 9, so we have 9 plus c is equal to 2. So c is 2 minus 9, which is equal to -7. So c is -7. Like that. Then, if we add again the coefficients of x squared, 2ax squared plus bx squared, these they should give us 24x squared, meaning 2a plus b should be equal to 24. So where there is a, because we know a, we have 2 by 9 plus b is 24. So b is 24 minus 18. So b is equal to 6. Implying that the solution is going to be 24x squared plus 2x plus 117 over x, 2x squared plus x plus 13 is equal to a. What is a? A is 9. 9 over x plus b, 6x minus 7 over 2x squared plus x plus 13, which is the partial that we have in that order. So you see where you can't reduce, you introduce bx plus c on top. Where you can reduce, we reduce. If it was repeating, would have said plus dx plus e over that thing squared. To answer it simple this way. Okay, so these are, yes.
Can you tell us if can you repeat what you've just said?
So I was saying if there was a square here, then the question would have changed. You say, okay, because of that square, then I'll add dx plus c over 2x squared plus x plus 13 to the power 2. Would have taken it as a repeating thing.
Okay.
Yeah.
So I have a question again. So this method for after arranging them with the A's and the
Yes.
be applied to the first question we did.
Yeah, you can apply if you expand. Just to give us the same thing.
All right.
Yeah. Okay, so we can cut and rejoin.